So I hope you have understood the first three topics: definition, representation, and terminology topics. So in these three topics, not many problems will be asked in the exams. But if you are to look at the types of problems that might be asked from your very basic understanding, so the problem types might be based on your understanding of a roster and set builder form. So might be asked questions based on this understanding. So next, you'll be asked questions based on the difference between the symbols belongs to and subset of. So there are two symbols that you have learned. In the definition topic, you have learned the symbol belongs to. Every element of a set belongs to the set. And in the representation topic, or in the terminology topic, you have learned about the topic subset. So you'll be asked to see the difference between belongs to and subset of. And third type of question is the question on number of subsets. You might be asked questions based on the number of subsets. So we have not done this in the terminology part because you'd have forgotten that. So number of subsets, you have to remember this very carefully. So number of subsets of a set depends on the number of elements of the set. So if n of A is equal to P, that means if there are P number of elements in the set A, then the number of subsets will be equal to 2 power P. So if a set has P a number of elements, then the number of subsets is 2 power P. So this is the only formula that you have in the first part of the set theory. So number of subsets is 2 power P. And finally, you might be asked questions based on open and closed intervals. So these are the four problem types that we are going to discuss in the first topic. All of these are very basic questions. So welcome students. So let us look at the problems based on the set builder form and roster form and in their interconversion. So first, let us say that you are given that A is a set containing an element x such that x square plus x minus 2 is equal to 0 and x belongs to R. What is the roster form of this set? So this set contains the element x such that this equation is valid. That is, if this x satisfies this equation, then it belongs to A, otherwise it does not belong to A. Now, what are the elements that belong to A? How do I get it? That can be obtained by just solving this equation. So you know how to solve the quadratic equation. X square plus x minus 2 is equal to 0. So if you factorize this, you get x plus 2 into x minus 1 is equal to 0. X plus 2 into x minus 1 is equal to 0. This implies x is equal to minus 2r plus 1. That means if this x square plus x minus 2 has to be equal to 0, x has to be either equal to minus 2 or 1. So these are the two elements which satisfy this equation. Hence these are the two elements which belong to set A. This implies set A in roster form is nothing but minus 2 comma 1. So this set contains two elements. So I can write n of A is equal to 2. If you're asked to find the number of elements in A, that will be equal to 2. So next, let us go to this question. So what does this set mean? B contains elements of the form x cube such that x is an integer and x square is less than 4, less than or equal to 4. So you know what integers are. So what are the integers such that their square is less than or equal to 4? So if their square has to be less than or equal to 4, x can be either minus 2, minus 1, 0, 1 or 2, right? So if you have the integers which are other than this, their square will be greater than 4. So minus 2 square is 4. Minus 1 square is 1, 0 square is 0, all those are less than 4. Now, if x square is less than or equal to 4, then x has to be any one of these 5 integers. But my set B does not contain x. My set B contains elements of the form x cubed. So what is my set? My set contains elements of the form x cubed, that is x takes these 5 values. So and my set contains x cubed, that is minus 8 for this, minus 1, 0, 1 and 8. So this will be my set. So before such that you have the form of the element. This is the form of the element. Now C is a set which is given in roster form 12, 18, 24, so on up to 96. So what is the set builder form for this? So to understand the set builder form, you need to find the pattern here. So what is the pattern that you observe? So as you can see, 12, 18, 24 are multiples of 6. 6 into 2, 6 into 3, 6 into 4, so on up to 6 into 16. So what is the set builder form for this? I'll make use of that property. C is a set containing elements of the form 6n, right? So all the elements are multiples of 6. So they are of the form 6n, such that n belongs to natural numbers. Yes, n takes values of natural numbers, but not all natural numbers. And what is the range of n? N is lying between 2 less than or equal to n less than or equal to 16. So n starts from 2 and goes till 16. So n is taking these values, but the elements in my set are of the form 6n. When n is equal to 2, you get 12. N is equal to 3, you get 18. N is equal to 4, you get 24. So on n is equal to 16, you get 96. So this will be one of the possible set builder form for C. Next, D is such that D is a set containing x such that x is prime and a divisor of 6. So if you take the divisors of 6, so divisors of 6 are nothing but 1, 2, 3 and 6. These are the 4 divisors for 6. But D is a set containing only those x's where x is prime also. Apart from being divisor of 6, x has to be prime also. So out of these 4, as you can see, only these 2 are primes, right? So this implies that D's set builder form will be set containing 2 and 3. So what is the number of elements in D? Again, equal to 2. So here, if you take the set B, the number of elements in set B is nothing but 5. Similarly, the number of elements in set C is nothing but the total number of elements is equal to 15. So I hope you understood the conversion from set builder form to roster and roster to set builder form. Now let us go to the second type of questions. So now in this question, we are given that the set A is a set containing elements 1, 2, set 1, 2, 3, set 2, 3 and 5. And you're asked to fill the blanks with either belongs to or subset of. So let us look at the first one. So I want you to just remember what belongs to and subset mean. So when you use belongs to, you should have an element. So we know that every element of the set A belongs to A. And whenever you use subset, a set is a subset of A if the set contains the elements that belong to A. So if each element of a set also present in A, then that set will be a subset of A. So if you take the first blank, 1 is obviously an element of A, right? 1 is an element of A, so 1 belongs to A. 1 is not a subset of A because this is not a set. 1 is an element. So 1 is not a set. So there is no question of being a subset. So 1 belongs to A. Next, let us go to the second one. Set containing 1, 2. Is it a subset or does it belong to? So what are the elements present in A? The elements present in A are 1, 2, set 1, 2. As you can see, set 1, 2 is also an element of A. So you have 1, 2, 3, 4, 5, 6 elements. So you have 6 elements in A. So one of the element is set 1, 2. So obviously set 1, 2 belongs to A is right. But as you can see, if you take set containing 1 and 2, the element 1, take the element 1 is also present in A. The element 2 is also present in A. So if you take this as a set containing 2 elements 1 and 2, 1 is also present in A, 2 is also present in A. So this set is also a subset. So set 1, 2 belongs to A as well as set 1, 2 is a subset of A. So here in this blank you can have both these symbols, both are right. Let us go to the next question, set containing 2, 3. So as you can see, set 2, 3 is an element of A, so belongs to is right. And the elements 2, 3 as you can see also belong to A. The elements in this set also belong to this A, hence subset of is also right. So for these two sets you can either write belongs to or subset, both are valid. So now let us go to set containing set 2, 3. Set containing set 2, 3, does this whole element belong to A? No. Set containing set 2, 3 is not there as an element of A. So belongs to cannot come here. Now if you take the set, this set is containing set 2, 3. As you can see, set 2, 3 is an element of A. So this belongs to A, hence this set is a subset of A. Next, phi dash A. So phi is nothing but empty set. You know that empty set is a subset of every set. Empty set is a subset of every set. But as you can clearly see, phi is also an element of A. So phi is also an element of A, so phi belongs to A is also right. So you can either write belongs to or subset of, both are right. Let us talk about set phi. Set containing phi. So is there a set containing phi as an element of A? No. But a set containing phi is an element of set A, so phi is also contained in A, hence set containing phi is a subset of A. Set containing 1, 5. So as you can see, 1 is an element of A, phi is an element of A, so set containing 1, 5 is a subset of A. Set containing 1, 2, 3, 1 is present in A, 2 is present in A, 3 is also present in A, and set containing 1, 2, 3 is a subset of A. So as you can clearly see, you need to understand the difference between belongs to and subset. A subset is always a set, and whenever you write belongs to, you write an element belongs to A. So if you have 6 elements in A, there are only 6 belongs to relations. So 1 belongs to A, 2 belongs to A, set 1, 2 belongs to A, 3 belongs to A, set 2, 3 belongs to A, 5 belongs to A. There are only 6 of them, but they can have a lot of different subsets. So now let us go to the next type of question.